Hey guys, all right. So 8.4, volume of rectangular prisms. Let's do this. And I'm trying to use this technology, which is really awesome, and it's not that great. And it's working now. Okay, here we go. Volume of rectangular prisms. Here's the question you want to be able to answer at the end of this. What? Ooh, this looks so good. What is volume? And we're going to go over that so many times, but you really want to be able to answer that question by the end of this, especially to differentiate it from area and from perimeter. Okay, so I'm going to go through with a highlighter here. Key idea, volume of a rectangular prism. So, every time we do this, it's important to ask yourself that you understand what those words are. What is a rectangular prism? Well, there's a base, and the reason it's a base is because it has an identical parallel base. Any face that has an identical parallel face is also a base. And in this case, of course, these parallel two faces are rectangles. So the base is a rectangle. It's a rectangular prism. Prism means parallel bases. Okay, the volume V of a rectangular prism is the product. Wait, stop. Product. That means we're going to be multiplying of the area of the base and the height of the prism. Now that's weird. So volume includes area. And the reason for this is, and I'm going to do my best to drop. I don't know if it's going to come out very good here, but what we have is, say the bottom is the base in this case. The base is filled with squares. Oh, look how good the drawing is. It's incredible. Okay, say the base is filled with squares, right? And what is area? It's the number of squares it takes to completely cover a two-dimensional space. I'm not drawing it well, but imagine that there's a layer of squares down here, and I guess I'll just finish it up. Next time I should just go diagonally, huh? All right, well, next time we have a pandemic, I'll do it that way. Okay, you have this layer of squares at the bottom here. If you find length times width, you find out how many squares it takes to cover that rectangle. Well, that's also the number of cubes. If you think of this as a layered cake, if you think that those squares, if instead we think of them as a layer of cubes along the bottom of this thing, okay, I'm not drawing it very well, but you get it. There's a layer of cubes here, and say that there's, 2 layers or something, and so the height is 2. So you have a layer of cubes times however many layers you have, you find out how many cubes it would take to fill this thing up. And that's really the answer to our question. Volume is the number of cubes it takes to fill a three-dimensional space, whereas area is the number of squares it takes to cover a two-dimensional space. Volume is the number of cubes it takes to fill a three-dimensional space. Okay, so the reason that area is in this is because the number of squares, area, at the bottom layer is also the number of cubes, volume, in the bottom layer here. And then you find that number of cubes, you multiply it by the height, you have the volume. Okay, let's take a look at an example, and maybe that can help us understand it even better. So, question. How can I find the volume of a rectangular prism with fractional edge lengths? I don't even know if that's proper English, but okay. Here we go. Find the volume. Wait, volume, that's the number of cubes it takes to fill in this whole three-dimensional space, and it turns out that this is a prism. Now, I didn't go over in the key idea the formulas, but that in part was on purpose, because here is what every prism in the world, you can find the volume by using this formula. V is equal to capital B times H. That capital B is the area of the base. So that capital B is the area, and this thing writes really well, area of the base. Okay? And then we're going to do a little over here times the height. Okay, so the volume is equal to the area of the base times the height. Well, let's see this thing. What do we got here? Well, it's a rectangular prism because the bottom rectangle is identical and parallel to the top rectangle, but so is the right side, right? The right side could be the base because you have a rectangle here that's identical and parallel to this one, or even the front could be the base, right? Because the front is identical and parallel to the back. Well, we'll consider the bottom the base, so I'm going to just outline it. And so what we're going to do is we're going to find the area of this rectangle, because that number of squares, however many squares it takes to fill this up, is going to also be the number of cubes, volume, that it takes to fill in the bottom layer. So you guys know I like to organize things, so we have our equal signs all lined up. As you can see, I'm really good at using this new writing pad I've got. If we don't change the left side, I can leave it blank, right? Saves me from having to write the letter V, even though it wouldn't have been a big deal, but there you go. Area of the base. Well, this is a rectangle. How do we find the area of a rectangle? Well, we've used base times height a lot, but if I use base times height, I'll have two h's. So I'm going to use length times width, right? So the area of the base is length times width, and just to make sure you see what's going on here, that area of the base is the length times the width right here, right? This times this. And they are, of course, perpendicular, because squares are perpendicular, and after all, area is squarea, right? So we have a perpendicular side there. And then we're going to multiply that by the height, which is like the number of layers in this cake, which turns out it's not even a whole layer. It's only 5/8. Okay, equal sign goes here. Now we substitute in our values. L, let's say it's 7/8. I like substituting into parentheses. It just reduces the probability of making an error. Width, perpendicular to the 7/8 is the 1/2. And then finally the height, which is the number of layers, which is going to be 5/8. 5/8. That 5 did not come out good, but you guys get the point. Now, what I didn't write, and I should have, is that all of these are meters. And I can write that meters on the top in the numerator, but there you go. These are all meters. We'll get back to why that's important right now after we finish multiplying. Okay, 7/8 times 1/2 times 5/8. And this is a good reminder that you can cross-cancel across multiple factors. Now, I don't see any that cross-cancel. 5 doesn't cross-cancel with 2 or 8. 7 doesn't cross-cancel with 2 or 8, and 1 doesn't. So we're just going to multiply straight across. 7 times 1 times 5 is 35. Over 8 times 2 is 16, or I guess I could do 8 times 8, right? Commutative property multiplication, that's 64 times 2, that's 128. Okay, now, volume. It's the number of cubes, right? It takes to completely fill in the space. Well, isn't this meters times meters times meters? Isn't that 3 factors of meters? That's meters cubed. And that's where that to the third power gets the name cubed comes from. This is how many meters cubed there are to fill in this whole entire space, which isn't surprising. That's a fraction because we don't even have a whole length meter on any of our dimensions. So it's going to be less than 1. I have found the volume. I've completed the directions. So what do we do? First, we wrote the formula to find the volume of a prism, which is always V equals capital B times H. The reason it's capital is because it's not a single dimension. It's not how long something is. It's going to be a complex variable. It means it's based on more than one variable. It's based on length and width. We substituted the formula to find the area of the base polygon, and the base here was a rectangle, as they will for all of the three-dimensional solids in this section. And then we substituted in the values for the length. Let's see if I can actually write this. We substituted in the value for the width, and we substituted in the value for the height. And then this says we're in 3D space, so, and I'll try to scroll down to see it. This wouldn't be a problem in class, but it's of course a problem here. Here in 3D space, our units will be cubed. Your units will be cubed. Okay? All right, moving on. Let's do this next example. I only have 15 minutes per video, so I have to go kind of fast. Okay, how can I find, hey, it is the same question. How can I find the volume of a rectangular prism with fractional edge lengths? This time, though, before we just jump into finding the volume, one time it's going to be 1 by 1/3 by 1/2. How many cubes do you think it takes to fill this thing? Foot cubes does it take to fill it in? I think it's good to estimate. Do you see that it's going to be maybe, I don't know, do you think a whole, is it even going to be one whole cube? So let's just, don't forget to, what can we do? We can, every time we do this, we can estimate the approximate number, the approximate volume to make sure we have the correct volume at the end. So I don't know. My guess is that we're going to have somewhere close to maybe a foot cubed. Just looking at these numbers, maybe a whole foot cubed would fill that up. But more importantly, this is a prism. What's the volume for every prism in the world? It's always the same thing. Capital V is equal to capital B times H. This time, the base is once again a rectangle. And just to show you we're not breaking anything here by doing this, I'm going to make this side the base. Why not? It can be a base. It has a parallel, identical face, right? So it's congruent, and so I have a base there. And the area of the base in this case is length times width because it's a rectangle. And then we're going to multiply that by the height. Put the little line down there, it's so straight. Length, we substitute into parentheses. I'm going to make that 1 1/3. I'm going to make the width, well, what's perpendicular to 1 1/3? The 1/2. And then the height, which is going to be 1. Now, this time I didn't put feet, and feet in here, but they are all going to get multiplied together. Why don't I put a little reminder for myself? Feet times feet times feet, that's 3 factors of feet, or feet times feet times feet. Now to multiply this, well, just like we did way back earlier in the year, let's convert this mixed number into an improper fraction. I'm just going to use dots now, times 1/2 times 1. Now the 2 and the 4 cross cancel. The greatest common factor of 2 and 4 is 2. I divide both 2 and 4 by 2. I get 1 and 2. 2 times 1 times, well, is this in the numerator or the denominator? If it doesn't have a roof over its head, no fraction bar over its head, this is in the numerator. So 2 times 1, that's equal to 2 over denominator. 2 times 1 times, the denominator of this must have been 1. That's 2. Or 1 foot cubed, which is beautiful because that's what I suspected it might be. By the way, I've already done this, so that's how I knew. I know. Don't be jealous. We've already filled in the first blank. Let's go to this one. Remember, you're finding the number of, is it squares to fill up? No, it's cubes that fill up the 3D space. Also, remember to convert the mixed number into improper fractions. That means that we have a numerator that's greater than the denominator before multiplying. Awesome. Thank you, guys. Sorry the video quality is not the best. We can't do a lot of the things we do in class, but do your best with this. And on Google Classroom, let me know if you have any questions. Thank you so much.